Okay, so it says a manufacturer knows that their items have a normal distributed lifespan. So as soon as you see normally distributed anything, it means it's going to follow this curve. So you're going to draw a straight line, then you're going to draw this like bell curve over top of it, roughly like the shape of a bell like that. Symmetrical, or at least it should be. The mean is going to be right in the middle, so it's going to be 9.9. And then sigma is 1.5. I'll just write this somewhere here. Standard deviation, little circle with the tail, is 1.5. So it says the 3% of items with the shortest lifespan. So that's going to be the 3% at the bottom. The shortest lifespan will last less than how many years? So we're saying the bottom, so if this area here is 3%, what value of x cuts that off? Cuts off the bottom 3%. Okay, so I think I looked at your problem set. You've got a lot of the questions done that ask you to find the percentage given a value. Now we're going to go backwards. So I have this percent here. Okay, I want to find the value. Before I do that, I'm going to use my z table to find the z value that cuts off the bottom 3%. So if you go to our Blackboard page, just had it up, there it is. Under course materials and statistics videos, if you go to normal distribution, at the bottom here, there should be, where did I put it? Put the z table, under here, how to find normal curve probabilities without a T-ID4. So the bottom of it is the z table. So what I want to do is I'm going to find, when this pops up, you'll see there's going to be a picture of a z table here. Okay, there's a z table on this picture on this page, and if you scroll down, there's a second page, the second second curve. This second table is for z values that are larger than the mean. Notice that more than half of this is filled in. The first page is for values less than the mean. Notice less than the curve is filled in. So we're going to use the top part because less than half of the curve is filled in here. So I'm going to look in this chart here and try and find 3%, or as close to 3% as I can find. So we're looking for the value that's as close to 0.03 as possible. So let's see here. It kind of goes in order here. So we have 0.0233, 0.0287. Looks like this is pretty close. 0.0301 is basically 3%. Okay, so that's going to be negative 1.88. You see that? Negative 1.8 is the ones in the tens place, and then 0.08 is 100, so it's going to be negative 1.88. So the z value that cuts off that bottom 3% is negative 1.88. Okay, so now all I'm going to do is take the z score formula, which is z equals x minus mu divided by sigma, and solve for x. I know z is negative 1.88. I'm looking for the x value minus the mu, which is 9.9, divided by 1.5. So the first thing I'll do is I'll multiply both sides by 1.5. So I'm going to have negative 1.88 times 1.5. So I get negative 2.82. Equals x minus 9.9. Then add 9.9 to both sides, plus 9.9. 7.08. So this value of x is going to be 7.08. The one decimal place would be 7.1. Okay, the important thing to know here is that the z table always gives values less than something. Okay, it never gives the area greater than something. So if I want to know, okay, well, what value cuts off the top 10%? Well, I can't look up 10% in the chart because that would mean this 10%. Okay, so what I'm going to look up instead is the value of z that cuts off the bottom 90%. And that's just something to keep in mind when using the z table.